Alright, functions is the name of the game in Algebra 2, and now we're going to make compositions of more than one function. We're going to put functions together. Now let's look at the vocabulary first. What does the word compose mean? Well, if you compose a song, you take all of your ideas and you put them all together and you create something new. If you compose a poem, you take a bunch of your ideas, you analyze the words, and you put it together to create something new. So we are going to compose or create something new out of other functions. This is what it looks like. Now, as in all things in Algebra 2, we have to understand what they're even saying to us. And what this means is find the composite function f of g of x. Okay. When you see this, this is the English translation of what they're asking you. They're telling you, please find the composite function of f of g of x. And you'll actually see it written more than one way, depending on which book, which test bank. And I actually like this other way better, and you may even want, a lot of people do, change, when they see this first one, they change it to f of g of x, because that actually matches the English a little bit better. But either way you want to do it is fine, but we have to understand what they're asking us to do. All right, there's the English part of that. Let's do a little more English before we get much further. All right, this is a standard function, but here's what I think it will be really helpful for you, is let's take just a moment to understand the English of this. This function says to take a number, that's the x, multiply it by 3, and then add 2. Isn't that what the function is asking you to do? Take a number, multiply by 3, and add 2. Okay? Then what is the English for my other function down here? Take a number, that's the x, then what do I do to it? I multiply it by 2, and I subtract 5. That's the English of what your function is doing for you, isn't it? And this is going to come in very handy in just a moment. All right, so now let's get down to the nitty-gritty. It is asking me to take, see right here, it wants me to find the composite g of f of x, and remember there's two ways to write it. It doesn't matter which one it is, they both mean the same thing. Now the key right here, and the problem, really the only problem you'll ever have with this, is remembering that you start on the inside and work your way out. It's like any other set of parentheses. Start on the inside and work your way out. So we are going to start, whichever way you've written it, and it doesn't matter, you're going to start in this problem with the f function. You're going to start, and what is the f function in this problem? Well, it's 2x minus 5. That's what we're going to start with. That's the kernel, that's the center. And now what we're going to do is we're going to add the g rules to it. In other words, we're going to do what g says to do. Well, what was it g said to do? Let's remind ourselves. The g function said multiply by 3 and add 2. Isn't that what the g function said to do? Alright, so let's start. Where do we start? We start with our f function. That's 2x minus 5. And now what are we going to do to it? We're going to do the g function to it. We're going to multiply it by 3, and we're going to add 2. Now some of you right here might have recognized, well, we really just took this and stuck it in here for x. And that's a good way to look at it, but I really, to build up our foundation, I need you to understand, we took the f function and we applied the g function rules to it. So this is what we have. Alright, so are we done? This is what we have. We have 3 times 2x minus 5 plus 2. Do you think we're done? Of course not. It never seems like we're done. So if I distribute and combine, what I'm really going to have, what is 3 times 2x? That's 6x. And 3 times negative 5 is negative 15. And then I'm going to add a 2, and I don't need the parentheses anymore because I did the distribution. I took care of the distribution, didn't I? All right. Anything else I need to combine? Oh yeah, I got to combine these two. So I have 6x minus 13. So my brand new composite is 6x minus 13. Well, I wonder if we do this backwards, because we did g of f, if we do f of g, will we get the same answer? Well, let's try it and see. So here's our g and here's our f. And what does this right here mean? F of g of x. So we have to remember where to start. We start with the g, don't we? We start with the g. We start with what's inside and we work our way out. So g is 3x plus 2, isn't it? 3x plus 2, that's what we have. Now, what were the rules again? I can't remember. What were the rules again for f? Multiply by 2 and subtract 5. Those are the rules of f, right? So again, what are we going to do? We're going to take g, and then what are we going to do to it? We're going to take g, and we're going to apply the f rules. And the f rules say multiply by 2 and subtract 5. Multiply by 2 and subtract 5. And again, you could say we took 3x plus 2 and we put it in for x. Alright, so what do we have now? We have 2 times 3x plus 2 minus 5. Are we done? We're not. So we need to distribute. So we have 6x plus, what's 2 times 2? 4. We don't need the parentheses because we did our distribution. And now we have minus 5. And we need to combine this. So what we have is 6x minus 1. Now, did we get exactly the same thing? Well, I'll remind you that g of f turned out to be 6x minus 13. So can you flip them over or do them out of order? You can't. You're going to get a completely different answer most of the time. There's a few that you're not, but most of the time. So there's none of this flipping it over or, oh gee, it doesn't matter which one comes first. We have 6 very easy little problems. Let's do the first 2. Alright, I need to remember where to start. If there was anything else I could help you do, it's to understand where to start. And we start with G. Now if you wanted to write it the other way, f of g of n, it might be easier to remember. That's where you start. You start with the one that's on the inside. Well, what is g? G is 4n plus 1, right? All right, now, what are the F rules? Take a number and add 3. Take a number and add 3. So what are we going to do? We're going to take a number and add 3. Am I finished? No, it seems like we've got to keep going. Do I need these parentheses? Parentheses indicate you need to do something. You need to distribute, you need to divide, but there's nothing to distribute here, so I actually don't need these parentheses. But what I do need to do is combine like terms, so I have 4n plus 4. So f of g of n, my new composite, is 4n plus 4. Let's do one more. Alright. Tell me what the rules are for my function real quickly. The rules of my function are take a number, that's a, multiply it by 3, and add 3. Alright, let's use our English. What in the heck does this mean? This is f of a. If you like the other way, f of a. Alright? Well, there's not two functions. How am I going to do this? Well, let's go through the same steps. If I start with f, I start on the middle, I start on the inside. If I start with f, what is f? 3a plus 3. There's my f. Alright. Now, what am I going to do to this? Well, let's go over our rules. Take a number, multiply by 3, add 3. So what am I going to do? I'm going to take a number, multiply by 3, add 3. If you like to think about it, you took this and you put it also back in as a, but I like to think it through better. That's my thing. Alright, now if I distribute, I have 9a, 3 times 3 is 9, and then I add 3, I have to combine, so I have 9a plus 12. Alright, you have 4 more to do. They're very, very easy. You need to be able to at least take a stab at them. They're just not that hard.